How does elasticity contribute to structural buckling instability? Imagine a tall, slender column standing quietly until suddenly it bends and collapses under a load. What causes this sudden change? The answer lies in the way materials stretch and bend under pressure. Elasticity is how a material responds when force is applied. It allows the material to deform temporarily and then return to its original shape once the force is removed. Think of a rubber band stretching and snapping back. This property is measured by the modulus of elasticity, which tells us how stiff the material is. The stiffer the material, the more force it takes to deform it. When a structure like a column or a beam is loaded, elasticity determines how it initially reacts. Up to a certain point, the structure stays straight and stable. But as the load increases, the elastic properties decide when the structure can no longer hold its shape. This is called the critical load. If the load exceeds this point, the structure suddenly buckles or bends sideways. The critical load depends mainly on the material's elasticity and the shape of the structure. A material with a high modulus of elasticity can support more load before buckling. The shape also matters. For example, a wider or thicker cross-section can resist buckling better. The classic formula for buckling shows that the load at which buckling occurs is proportional to the modulus of elasticity and the moment of inertia of the cross-section, and inversely proportional to the square of the length of the structure. Elasticity controls how the structure initially bends when a load is applied. It keeps the structure stable until the elastic limit is reached. At that point, even a tiny lateral movement can grow rapidly, causing the structure to suddenly change shape. This process is purely elastic because it happens within the range where the material still obeys Hooke's law, meaning stress is proportional to strain. The boundary conditions and the geometry of the structure also influence buckling. For example, supporting the ends of a column differently can change how easily it buckles. Increasing the moment of inertia by adding material farther from the center makes the structure stiffer and less likely to buckle. Understanding how elasticity contributes to buckling helps explain why some structures fail unexpectedly. They don't break because the material yields or cracks. Instead, they lose stability because of elastic deformation. This knowledge is essential for designing safe buildings, bridges, and other structures. It ensures that the materials and shapes used can withstand the loads without buckling prematurely. In short, elasticity determines how stiff a material is and how it responds to compressive forces. This stiffness controls the load at which a structure becomes unstable and buckles. Recognizing this helps engineers prevent sudden failures by choosing the right materials and designing structures that stay stable under expected loads.